2011, number 5. Hopefully you've read the question. Part A, use the tangent line to the graph at W at t equals 0 to approximate the amount of solid waste the landfill contains at the end of the first 3 months. And they're kind, and they tell you that t equals 1/4. So if you look at my work, what I have here, this is my given, and I also know that we're starting with 1,400 tons. My units are tons, I'm talking about years, and my start time is really 2010. So this is all my given information. I'm writing the equation of the tangent line, so that means I need to sub in. When x is 0, that's my start time, I have 1,400 tons. That was given to me. To find the derivative, I have to use my dw dt. I'm finding the derivative at time 0. So if W is essentially your y coordinate, you want to know at time 0 what is the amount of waste in the landfill, and that's your 1,400. You sub that in, and you get 44 as an answer for the derivative. You can distribute, you can solve that, and now I have to sub in, and so I'm subbing in 1/4 to get my final answer, because I want to use my tangent line to find the value at when t equals 1/4. Okay? For part B, I need to find the second derivative in terms of W. That's key right there, in terms of W. And then I have to use it to determine whether my answer in part A is an underestimate or an overestimate of the actual amount. So the key here is with the second derivative. If you're comparing the first derivative, which is given at the top of my page, when I take the second derivative, 1/25 is a constant out in front, times the derivative of what's in the parentheses is 1 dw dt. Because I took the derivative of the variable w, I need to tack that on. Now they want the second derivative in terms of w, so I can't leave this here. I need to rewrite this. So this 1/25 right here, that's right there, times, instead of dw dt, I'm replacing that with the original equation. 1/25 of w minus 300. That right there is the value of dw dt. So now I'm just combining, I'm multiplying my fractions in front. I get 1/625 times w minus 300. Notice this is now the second derivative in terms of w. So now I have to use this to see what's going on, to figure out what my approximation is. Now, they tell us in the beginning of this paragraph that W is an increasing function. So therefore, if we start with 1,400 tons and it's increasing, then no matter what number I plug in here for W, this is going to be positive because it's either going to be 1,400 or greater than that because it's increasing. So because of this, the second derivative will always be positive. If the second derivative is positive, then I'm talking about a concave up function. My tangent line approximation therefore underestimates. So in part A, that was an underestimate because my tangent line is lower than the actual curve because it's concave up. Okay? And then part C, again, if they're going to give you a question with a derivative, you're probably going to have to solve the differential equation. So that's what I need to do with my initial condition. So that means I have to find a value for C. I'm not going to leave a plus C. So when I look at this, here's my original. I need to separate the variables. So I multiply by dt, and then I divide by w minus 300. And then off to the side here, I think hopefully you can see this, I'm going to do a u substitution so that that integral turns into the integral of du over u, which is ln, absolute value, I sub u back in, equals, and then this is really 1/25 as a constant, so it's t over 25 plus c. Sub in my given information, and I find a value of c. Now I sub this value of c back into the previous equation, and my work is over here. So hopefully we can follow this. ln of w minus 300 equals, and notice I have my value of c in this equation. Drop the base. All my exponent comes over equals the absolute value. And then remember, when I break this up, it's e raised to the t over 25 times e raised to the ln of 1100. The e and ln cancel. 1100 becomes that constant out in front. And then I split and I look at the positive and negative answers to see which one actually checks. The positive value checks. So remember, you have to solve for W, so you have to add that 300 over. So therefore, W of t is 1100e to the t over 25 plus 300, and again, they're telling us that this is for the next 20 years, so that's what that is. In my given information, they tell me that this is the formula that works for the next 20 years, so that's what right there. But I don't think you have to have that because it doesn't tell you to put that there. It doesn't give you it doesn't ask for the domain, but that's where it comes from. Hopefully that one wasn't too bad.